Hello and welcome. I've been wanting to put these keyhole slots into some of the signs and stuff in art that I do, and frankly, I couldn't find anything in YouTube or whatever that said how to do this in Fusion on a CNC. Um, Both creating the keyhole, but also defining a tool to do it. While you can buy these keyhole bits, there's nothing in the default libraries or any of the tool libraries that I've downloaded from where I buy my tools that define a keyhole cutter. Um, so I've designed this keyhole as a test, just as an example, for myself, really, just to learn how to do it. And so I'm just documenting what I did. So hopefully this helps somebody else out there that wants to do the same thing in Fusion. Um, so let's start with defining the keyhole. What I did was I just created a little 8 by 10 plank and extruded it to 3/4 of an inch. I'll back up in the timeline here so I can kind of go step by step. So first I created this sketch to lay out the basic keyhole. So I've got a slot defined for the bottom part of the keyhole, and another slot defined for the outer slot where the screw would slide through. And then this circle is the hole that will be cut to get down to the lower level. So first I extruded the, let me finish that sketch. I guess I could give you details, but it's all right here. It's like my outer tool dimension is, for this particular keyhole cutter, it's 3/8 of an inch in diameter on the bottom of the slot, and it's 1/4 of an inch cutter for the top of the slot. And so that's what I mean. The inner is 1/4 inch, the outer is 3/8. So first, I extrude the upper slot, or did I do the bottom slot? It looks like I extruded the bottom, and so that extrusion. I'm sorry, no, this is the actual plank that I extruded. Let's move on. Okay, so I probably should have done these the other way around, but what I did was I extruded the bottom slot first, and that's an offset extrusion. So my cutter is 3/16 of an inch, so I did a 3/16 inch extrusion, and my starting point was an offset, and I wanted to go down 3/16 of an inch so that my upper slot is going to be 3/16 of an inch deep, and my bottom slot will be 3/16 of an inch deep. Okay, and because I'm going down, they're negative numbers. Okay, then I'm going to extrude the upper slot. I'm sorry, no, I extrude the hole that cuts down into there, and that's going to be 3/8 of an inch deep. And then I extrude the upper slot. Another cut for 3/8 of an inch. And that defines it. And to be honest, actually modeling the keyhole slot's not really even necessary. All you really need is this line that defines where you're going to put it, because we're going to use the trace tool to cut it. So the advantage to actually modeling the keyhole is in my next sketch, which it gives me a plane down here in the bottom. So I did my next sketch on that bottom plane, And all I did was project that line from the upper sketch onto that lower plane. And that way when I do my trace, I can do it on that projected line and not have to set any offsets for the trace to put the tool down into that hole. So once I had that, I'm going to go over to manufacturing workspace, and all I did was a trace, toolpath, choosing my keyhole cutter, which I'm going to show you how to create your keyhole cutter in just a minute. This is what I created. Say okay, and our geometry is going to be that bottom line there. Looks like I chose the top line. You could sorry, don't mean to confuse anybody, but what I did was I chose the top line and I set an axial offset of 0.37. 375 actually, it truncated the 5. But I could have chose the bottom line. In fact, I'm going to go do that. I'm going to get rid of this. We're going to delete that one, and we're going to select this line instead and say okay. Not okay. We're going to go over here and we're going to do a couple things. We want to do repeat pass because we need it to go down and back before it comes out of the hole. So the repeat pass will do that. I checked both ways. And on linking, we want no lead in and no lead out. We just want it to leave those off and let it do a plunge and then run the trace down and back and come out of the hole. So we say okay on that. And if we go to simulate and run the simulation, it's going to go down, it's going to run across, it's going to come back and come out. Simple as that. Something didn't look right though. Yeah, something didn't look right. I don't know what, but something. Oh, I know why it doesn't look right. It's exit simulation. I forgot to take off that point, that axial offset. We got to take that off, so that's going to be 0. And then we'll run simulate. Down, over, back, and out. And see, now that looks right. So now we need to make the tool to do that cut. So to do that, we have to make a form tool. So to do that, what I did was I created a sketch that models 1/2 of the tool, the right side of the tool. So I took all the measurements off the tool for the bottom cutter, the middle cutter, this little yoke or shaft that before the major shaft, and then the length. And so I took all of those, divided, except for the lengths. The heights are full heights, but the diameter is really a radius. So we took the radius of these cutters and the shaft and drew half the tool, the way you would if you were going to do a revolve on this. That's what we would get. I'm not going to do that finished sketch. So whatever keyhole cutter you're using, you would just get your own dimensions off of your specific tool and create this model however you see fit to do that. what else do I need to say here? Not much. If we were to revolve this, that basically would give us a model of our tool. We don't want to revolve it though. What we're going to do now is go to the manufacturing workspace, and we're going to manage form mill. And this will allow us to create a form mill from this. We're going to select our tool profile, which is our tool shape that we did in that sketch. Our tool axis is going to be this vertical line. The arrow should be pointing down. If it's not, you're going to flip the axis. I'm pretty sure. I know if it was pointing up, for me, it had made the tool upside down. So then we're going to do our compensation point. And this can be a challenge. And I don't know why. I don't know if it's because it's on the origin or whatever. But if I select that, I can't get it to choose it. So what I do is I go over and choose the right side. And then I go back and pick the left side, and it seems to stick when I do that. I don't know why, but we got it, and that's it. And then you click OK. And now if you go to your Manage Tool Library, you'll see that new form mill that you just created right there. What I had to do was I had to copy it. Oops, I didn't want to edit it quite yet. Go back to Tool Library. The first time I did this, I edited it right here in place, and then when I went into my other model to use the tool, I couldn't find it anywhere. So what I did was I did a copy, and then I chose my local library and did a paste, and then I edited it in here. And when I did that, I was able to find the tool in my local library. Okay, so then you're going to want to edit it and give it a name. Under General, you're going to give it a description that describes this particular keyhole cutter. On the cutter, I set the material on mine to HSS. I'm not really even 100% sure what it is. It might be, I'm pretty sure it's just high-speed steel. I'm pretty sure it's not carbide. And the flute lengths that it would have by default, here, let's go look at the default one instead. Let's go to Tool Library, and let's edit the one that I just created, and you'll see that the cutter has the flute length, the full length of the tool. So I shortened the flute length down to the combined length of my two cutters. Which I think was 0.425, something like that. And when you do that, you'll see on the tool that it will now reflect that that's the only part of the tool that's a cutter. I also changed the length below the holder to just 1 inch instead of the full length of the tool. And that's it. In my post processor, I gave it a tool number of 22, whatever you want to do there. And under cutting data, I set my spindle speeds to 18,000 RPMs. And then I set a really slow feed rates of 12 inches per minute, because for this operation, I want this tool to move really slow. I want it to just go down and slowly go across, because it's cutting underneath. There's no way for those chips to evacuate properly or anything. So I just want it to go really slow and try to avoid any chip out on this cut. So I set all of my speeds, my vertical feed rate also to 12. And I disabled coolant. Once you've done that, then you can go back over here and you should find that tool in your local tool library. I called it tool 22 right here. and there's my tool. So that's it. Don't want to make this any longer than it is, so hope that helps somebody out there. Any questions or comments, I usually reply within a few hours of any replies on any of my videos. Take care. Have a great day.